In this video, we'll be talking about the reaction pathways of SN1, SN2, E1, and E2. Now, what is it that made them so difficult for me in particular and for a lot of other people in this class? For me, the biggest part of it was the fact that it was just a lot of rote memorization. You had to remember exactly what reactions did what, how they went, the properties that bring them about. And related to these problems were a couple other important things about reactions in this class, being something like recognizing resonance. Another concept that has been a little bit difficult to handle, as I'm sure it is with most other people in this class, is the next step after looking at these reaction types is the reaction pathways. Reaction pathways, the reaction mechanisms, things like that. And one thing that's important about those is these. In order to recognize these mechanisms, and particularly the pathways of these mechanisms, is to know first what kind of reaction they're going to undergo. Is it synthesis? Is it elimination? What type is it? And you really have to have a mastery of these types of concepts before you can have a mastery of these. Now, what is it that made it so that I could understand these? And there are a couple different strategies that I did in order to understand these further. Things like SI sessions. Once I start going to SI sessions, it got a lot easier to understand these concepts. And going hand in hand with the SI sessions would be just practice. Just got to keep writing it down. Things that have so much rote memorization like these do just require lots and lots of practice. And some of that practice will come from the homework, some of them will come from the SI sections, and some of them you can see examples of when you look at things like YouTube videos. Those can be very helpful, and particularly, Khan Academy, which I'm sure all of us are familiar with. For our example here in this video, we'll take a look at, let's say, bromine here, 2-bromobutane. Now let's react that with, let's say, ethyl alcohol, CH3CH2OH. And we have to recognize what kind of reaction will take place here. If we take a look, we'll see that this is a tertiary substituted carbon atom with the 3 groups here. And so tertiary seems like it's going to undergo SN1 reaction. What we'll see happen will be the bromine here be a very good leaving group because the bromine is electrophilic. The electrons are going to get taken from the bond here, as the bromine is going to leave the butyl group here. That's going to leave us with a carbocation here. And now we have a carbocation that really wants to react, and also a nucleophile up here. The nucleophile is going to come in here. It's going to be the 2 electrons here that are going to be attached here, and results in something that looks like let's get this up here. Have an OCH2CH3 group on here. And one thing that's important to note also is that this can be, in terms of stereochemistry, it can be from behind or it can be in front. Because they're doesn't have to be a sort of backside attack that will invert, like in SN2 reaction. And this will be our final result in this reaction. Necessary to know that it is a SN1 reaction. That's how we know it takes place the way it does.